Assalamualaikum and selamat sejahtera to sir. My name is Muhammad Arya Iman bin Abdul Halim and I'm from Section 1 Group 1, and I would like to present about our mini project that is DC-DC booster converter circuit. So for the introduction, one of the most basic switch mode converters is the boost converter. It is capable of converting low voltage DC input to high voltage DC output. So we use an inductor, a semiconductor, a diode, and a capacitor for our circuit. So the DC-DC converters are widely found in portable electronic equipment like cell phones and laptop computers.
Assalamualaikum warahmatullahi wabarakatuh, and hi sir, my name is Muhammad Iqbal Hafiz Firmaizi, the presenter of this part, which is simulation of MATLAB. So for switch I use MOSFET. I also use display to display the voltage output and current output. I also use scope to get the waveform of voltage and current. And for here, for the parameter, for frequency and duty cycle, we use 50 kHz and duty cycle 0.8, which is 90%. And for the other thing, the other parameter we use as instruction given. So, and we got the output, voltage output 240 volt and current output 23.39 ampere. This is output current waveform that shown in our scope. For the Imax, we get 25.3, and for the Imin, we get 23.4 ampere. This is our output voltage waveform that we get. For the first cursor, we get 240, and second cursor, we get 239.25. For voltage ripple, we just have to minus this value and get 0.75. And also this is our output pulse generator waveform. This is the detail of how we get the calculation, the derivation, the equation derivation for above, and there's also assumption for the simulation part. This is calculation that we get from the formula that we used, and this is the result of our calculation. This is the table of comparison between calculation and measurement. As we can see here, there's more or less the same between these two things, calculation and measurement. It's proof that our calculation is true by go through the measurement.
So for the discussion, the area of rectangular below the time axis, which indicates changes in charge delta Q, may be seen in the result. The ripple output voltage can be calculated using the change in charge formula. The switching frequency and capacitor value are indirectly proportional to the output ripple voltage. As a result, by raising either the switching frequency or the capacitor value, the ripple output voltage will be reduced. So that's it for our group. Thank you, sir, for your time, and have a nice day.